Okay, so for day one of chemical reactions, we actually do a review of everything that we've been doing. The first couple of pages should be an easy review. You could easily find all of these definitions in past notes if you've saved them, and if not, they're all over the internet. When you move on to the third side of this assignment, that's where we get to naming of ionic, covalent, and organic molecules. Now, I will post on Schoology the information that I have here on my iPad, but you will need to know this information for a quiz that we will be having. Now, I figure we can review ionic naming first, and it would be a good idea to ask yourself every time you're doing one of these if the first element is a metal. If it is a metal, then you would use the ionic naming techniques, which would usually be a metal plus the nonmetal, and you change the ending to IDE for the nonmetal. Now, don't forget that the staircase is right here, and anything to the right side is a nonmetal, everything to the left is a metal. The first metal that I see on here is potassium. You would also have to know your ions. If you remember, here we have phosphate. So this one would just be called potassium phosphate. Here we have silver and we have chlorine. It would simply be called silver chloride. Those were the easy ones. The ones that became tricky are the ones that are transition metals. If you remember, the transition metals are the ones at the center of the periodic table, and their oxidation numbers change, they transition, and therefore they can be many different oxidation numbers depending on what they're bonding with. Now, there's a couple exceptions to the rule. Silver and zinc always have the same charge, so you could always find these on the ion sheet. But lead, on the other hand, is not a transition metal. However, the charge does change, so that's the other exception to the rule. Be prepared for that one, especially on the quiz. So I look down here, and we have copper and sulfur. Let's focus on that one. We have copper, which is a transition metal, so we know that the name of it will be copper. We know the ending is sulfur, so it will be sulfide. But because there's a 2 here, we're going to need to figure out what the Roman numeral is. Remember, if it's a transition metal, when you name it, you put the Roman numeral on there. Okay, so if you look up the charge for sulfur, it's a -2. Copper, even though we don't know what it is, what we do know is that the oxidation numbers must be equal but opposite. Therefore, we know that all of the copper ions together would have a +2 charge. But because we have 2 coppers here, this little subscript tells us we have 2 of them. That means each individual copper has a +1 charge. They're both using this +2 charge. So together they add up to be +2. So because it's a +1 for each of these 2 coppers, we would put a 1 for the naming. Okay, let's try one more. We have lead and oxygen, which, remember, lead is an exception to the rule. Although it's not a transition metal, it does have a transitioning oxidation number. So we know that the beginning of the name would be lead. We know that the ending is going to be oxide. We do not know what the Roman numeral would be, but we do know this, that oxygen is always a -2 charge, and I have 2 of them here. So that makes it a total of -4, meaning lead could be nothing other than +4. Remember, oxidation charges have to be equal but opposite. Therefore, this would be called lead 4 oxide. Okay, now that we've done ionic bonding, let's try one that has covalent bonding. That would be 2 nonmetals. And don't forget your prefixes for covalent bonding. Now, there's 2 types of covalent bonds. There are the traditional, where you have any 2 nonmetals, and you would use the first set of prefixes. If it's organic, meaning it's made up of carbon, hydrogen, or hydroxide, you would use the organic prefixes, and you would have to use the right ending. Now, I can tell you on this quiz, we will only be focusing on the alkanes, so I have crossed out the second 2 examples. You would still need to know this formula, because if I gave you the name of it, you would need to determine how many carbons and how many hydrogens are available. So let's try one that's a covalent, meaning just 2 nonmetals, one that's not organic. I look here and I see that we have one right there. We have nitrogen and oxygen, but don't forget the rule. Now we're using prefixes, but only the prefixes for covalent bonding. So we have 2 nitrogens, we would call it dinitrogen. And there's only 1 oxygen, so it would be monoxide. You do not use the mono prefix if it's on the first element. Do not forget that. You need to know that. Okay, that's how you would do all of the covalent naming for 2 nonmetals. If we have an organic compound, such as this one, we have 1 carbon and 4 hydrogens. Well, the prefix for 1 carbon is meth. And if we were to take that 1 carbon and insert it into this equation, we can see that 2 times 1 is 2, plus 2 is 4. So that means that we must have 4 hydrogens in this compound, and the ending is -ane. Okay? Okay, now the other way that you will need to know these is if I were to give you the name of it, and you have to determine the compound. Okay, so if we have copper 2 oxide, we can see that it's a transition metal, meaning that the charge will change. We have copper. We have oxygen. We know that the charge on this is positive 2. How do we know? Well, it tells us. So if copper is a positive 2, we know oxygen has a negative 2 charge. You can look at it on the ion sheet. And so we're done. It's just one of each. The oxidation numbers have to equal 0 when added together. These, if it's a diatomic molecule, don't forget that they are actually diatomic. So, so bromine would have the little 2 there to indicate that it is a diatomic molecule. Let's try this next one. We have butane. Now, the but prefix tells us that we have 4 carbons, and we can go ahead and write that down. Now, the equation, again, to find the number of hydrogens, 2n plus 2. Since we have 4 of the carbons, it's 2 times 4, n is 4, plus 2, that would be 10. So hydrogen 10. So that would be organic compound for butane. Okay, you should memorize ammonia at this point. There's a few that you will see time and time again. There's ammonia, there's hydrochloric acid. You should know sulfuric acid. These are common acids that you should know at this point. So sulfuric acid, we have H2SO4. Make sure you memorize that. Okay. Now, what about something like chlorine pentafluoride? You would have 1 chlorine and 5 fluorines. So those are easy to name. The ones that get difficult at this point would be the ionic, because you have each one. We have the magnesium, we have acetate, which is actually, if you have to look it up, go ahead and do so. But acetate is C2H3O2. Now, acetate has a -1 charge, and magnesium has a +2 charge. So in this case, you would have to put this polyatomic ion in parentheses and put a little 2 here to indicate the crisscross. Now, when you bring the 1 down, we don't actually write the 1. And I'm going to erase these because they're not actually supposed to be shown when doing this. Okay, so that covers every possible scenario. You better get it. Bye.